Hi, my name is Christiano. I work for PayPal, and I've known the DevOps guys for a while. And when I was, I wanted to sponsor DevOps for a while. So when it finally came to London, we were pretty happy. We couldn't do it last year, but this year we're finally here. I was trying to put a talk in, and I was like, what would be the most interesting thing to do at a Java conference is to talk about why PayPal's no longer using Java. So please don't kill me. A while ago, we kind of made so we've been moving to Java from Java to Node.js for various reasons. And a couple of months ago, we released our engineering team released some nice charts that show that Java is slower than Node. This was the wrath of every Java developer out there that was coming our way, and it was painful. Because I think any decent software engineer knows that the speed of any kind of app, any application is only to a certain limit, determined by the language it is written in. There are so many other factors. So I'm going to talk you kind of quickly through why we changed from Java to Node, and kind of the changes that we have made and why they have given us a pretty increase in our production and in our production apps, and how their response times actually are a lot faster now. But I'll also show you that Java doesn't really have much to do with it. This is a story of like technical debt, right? When PayPal started, this is what it looked like, right? This is PayPal kind of early 2000s. I have to admit, until recently, it still looked like this. It's taken a really long time to make any changes, and this is the technology that powered us. We had a lot of Java, and then we had a lot of C++ in the bits where we wanted to be faster than Java. And this black line around this is very important, because that was one app. We had one app that was running PayPal, which was a disaster. We had some differences when it came to like production and prototyping. So at some point we bought some very interesting companies. We bought some companies that included some former Netflix people. We bought some mobile companies, and they were doing a lot of prototyping. They were doing a lot of rep development in Node or in Ruby or in any other language that they really were interested in. And then basically it had to be moved from that production, from that prototyping environment. It had to be moved into our production environment, which was its own framework. And this is, it took us, I think on average, it took us like 6 weeks to really make any changes just in the copy to the website. And we couldn't live with that anymore. So a couple of years ago, the leadership made the decision to really start overhauling this. Because we didn't want it to be like this anymore. You guys know this scene from Indiana Jones, where he kind of like has to replace this kind of weight at the same time. That's kind of how our deployments felt like, right? It's like we just had to like, make sure it didn't go down as we were just, and that was for every typo that we shipped, we had to do this. So at the core of this was the fact that we had I think you see this at a lot of startups, is they at some point they go, this framework isn't right, that framework isn't right, all these frameworks aren't right. I am going to build my own framework. Which is great. It's a nice idea. Except it's not very nice if you don't ship it as open source, which is not what we did. Ours was called Sparta. You might see that we kind of have a repeating kind of preference for mythical creatures. And Sparta was, was built. It was our own framework, built on top of Java mainly, and it was really slow. It was really slow, but the main problem was not that it's slow. The main problem was that in Silicon Valley, which is where all of our development pretty much happens, there are not that many Java developers. Well, there are a lot of Java developers, but they're all working for other companies already, and there's a lot of other companies that are doing a lot of really exciting things. And none of these developers, none of these Java developers, except for the ones that work for us, knew how our framework worked, right? And this is the bigger problem, right? Is like we could spend a lot of time hiring somebody, and then we'd have to spend another bunch of time to actually teach them how to work with Sparta. So we couldn't do that anymore. And, this was like our average recruitment drive, right? We were trying to find people who were interested in working with a closed source Java framework. And, just imagine crickets. Nobody was particularly interested in that. So these guys came from Netflix. So this is what kind of happened at the same time. Jeff Harrell, Bill Scott, they're really awesome kind of front-end designers, kind of UX designers. And they were put in charge of kind of revamping our front end. So not really our back end, but mainly the way our site looks and feels, putting a consistent feel across all our different apps. So, they came from Netflix. And when you start looking at how our stack looks like, we actually had Java doing pretty much everything. Like the Java was generating the CSS, the Java was generating the JavaScript, the Java was generating all the backend, code. It was everything was Java. And then we had some C++, which had XML on it. Now, you can see that from a modern front-end engineer that didn't work anymore. So of course, the prototyping environment looked like this, right? There was a lot of Node, and there were a lot of just plain JavaScript for the actual front-end code. So what they started to do is Netflix actually launched this library called Dust, which is a templating library. And they did the sensible thing, right? They made their own templating library, and they open sourced it. So a couple of other companies picked it up. So at the time, we decided to pick it up too. So these days, a lot of our app looks like this, where we have different bits of code that all run in the background, but we have the Dust templating engine across all of these. So this is still Sparta. It's got a different name, I forgot what it's called. And then we have Kraken over here. I'll come to Kraken in a moment. Of course, it doesn't actually look like this. It looks more like that. Because one of the things we've been doing is turning PayPal into PayPal as a service. So taking that one monolithic app and turning it actually into different little applications that we can kind of pull and kind of reassemble in ways that we might want to use. Because what happens a lot is we work with like really big merchants, like say British Airways or something like that, and they might have very specific needs. Now we can just say, okay, you get all these like little modules, but we take this one out for you, and we'll give you a slightly different risk engine, and we'll give you a slightly different way of kind of getting paid out. We can plug and play these things as PayPal as a service. And of course, we moved away from good old Java. But that's not what cost us the biggest kind of performance hits, of course. Because we've been moving to kind of smaller, modular, more sustainable, more standardized, and more open source frameworks, that's given us a lot of increase in our production speed. So just to go through it, our CSS and HTML was built in Java. We had some JSP for templating. We now have a fully open source stack. It's mainly Bootstrap that we're actually using, but a very highly customized version of Bootstrap. The templating is done through Dust. We really improved our C++ by kind of bringing in the V8 stack. You got to think the bits where we use C++, it's our risk analysis and all these kind of like really computational heavy bits of our ecosystem. They are hard to replace and hard to speed up because they're so ingrained in what we do that the easiest way for us to get a really good performance hit on this was by just moving to the V8 engine. That doesn't really make that much difference, though, for the people at the front end, because this is barely ever the front end code that actually runs the C++ code. And then we wrote our own little library that basically does the Dust templating on top of Java. But the most important thing is we started to prototype all of our new apps, all of our new modules in Kraken. So Kraken is basically Express.js. You guys are familiar with Node? Yeah, about half. Cool. So for some people, it takes a while to realize Node is not really framework. Node is just a basically a flavor of JavaScript. Express.js is a very, very, very lightweight version, a very lightweight framework for doing websites. Now, it's very lightweight, and it's nowhere near suitable for anybody who basically wants to do an actual production environment, and especially when you're dealing with security like PayPal does. So Kraken is basically a couple of modules that we have on top of Express.js that really provide a lot of very opinionated, very standardized open source ways of doing specific things. So Makara and Adaro are they are ways of dealing with the Dust templating engine. So the one is provides the rendering of the templates. The other one kind of sets up the environment and especially the variables that you're trying to share with your templates up so that it can hand it on to Makara. Kappa and Luska. Luska is really important to us. It's just security. CSRF, XSS protection, all these different things that are just not there in Express.js by default. And Kappa is it's an NPM proxy, so it's basically like NPM is basically also a dependency management, and it's basically our own proxy so that we can run our own, basically our own modules of our own server, but then kind of transparently cache that to the public modules that are available, or actually fix them to specific versions on our server so we don't get certain surprises when a developer decides to ship a new version which has a massive bug in it, which of course to us is very, very important. And this is all open source. So we decided not to go the same route that we had before. This is open source. You can use this. There's a really cool generator that actually, so an NPM generator where you can just create a brand new Kraken project and just ship it. Just generate the whole stack, and it configures all these modules and how they fit together. Now, what's the result of this? The result is that we now have the same prototyping stack as we have the production stack. It's become ridiculous, a whole lot easier to hire people, and we're actually now working together with other companies. So Netflix has taken some of these gems back, some of these. Sorry, I'm a Rubyist actually, so I'm taking gems. Some of these modules back from us, and they are using them now. So we're building a community around all these products that we're using, and we have seen, we have seen an increase in our server response times. We have seen an increase in how well our apps work, but I think to say that that's simply because we switched to Node is an oversimplification. Thank you very much. That's it from me. If you have any questions, I'm happy to answer them.
So why didn't you open source Betta?
Because it wasn't very good.
So it was better to rewrite everything and hire new people and build your own framework so that open source is all one.
So the guys, Jeff and Bill, because they come from kind of a front end kind of perspective, the other push that was part of this is to kind of have this idea of one language between the front end and the dev end team that was shared. It's a common concept that's going around at the moment. I think it's still an unproven one whether or not it actually has its benefits, but that's what because this push was coming from the front end guys who felt that this had to change. That's why there was a switch to having a unified language between those two teams. It also means that the reason why we can make the team so much smaller is because they can easily we used to have these teams which were very, very specialized in very specific bits of the code base, where now we can kind of really ship them around to different teams and have smaller teams that can do more across the entire stack rather than just the back-end bits.
Do you find any...
Sorry. He put his hands up.
I have a follow-on from that.
Just wanted to ask you, so you keep saying that it's not necessarily because of Java bad. So what is it? Is it because you changed the way you work?
It's changed because we modularize things. It's changed because I think the majority of the code base was written in kind of early 2000s when the front end was very lightweight. where these days we have a much more heavy front end. Therefore, you start to kind of develop your app around that kind of principle of kind of sharing resources between the different bits in your app. Those things didn't exist, and those things now exist. But I think it's more an accumulation of that's what affects our kind of generally just our page speed. The development time just comes down to the fact that we can now prototype in the same language that we do our big, a big PayPal application, and they're split into PayPal as a service.
So I want to follow on from that question about people crossing over in teams. So there's two really different execution contexts: the browser and Node. And have you experienced any problems? Or, like, do you have rules about how people transition from one execution environment to the other? Because it seems like filled with risk, which you're not.
So the way, so the question was like, because there's very different execution environments between front end and kind of back end JavaScript, and I agree. I mean, that's well. So the question is whether or not we've noticed any issues with that. I personally, I think I totally agree. Like, they're very different, and that's why I said, like, I'm not sure. It's very early days for this. The nice thing, so Dust templating, it's a templating language that you can either compile client-side or server-side. So it gives us that flexibility to decide whether or not we want to render bits client-side or server-side. And the Dust...
It's a shared templating language. I think that's much less controversial than the two.
Yeah, but the Dust templating engine, it's very lightweight when it comes to actually running any JavaScript actually beyond that on the front end. It's very... It kind of abstracts that kind of responsibility of how do you develop in the front end versus how do you develop in the back end. It kind of abstracts that away. Get what I mean?
Not quite.
So certain.
It's just a templating language. You still have to decide what data gets presented to the template. Right?
Yes, but certain interactions, yeah. So if I want to interact on a page, and I want that to be loaded client-side and replaced client-side versus that happening through a data load on the server side, data load to the server, and then a render, and then a push back to the client, that's abstracted away by the Dust templating engine. So that can be configured by, if we go back, that can be configured by Adaro, whether or not that's handled on the client side or the server side. So you can program for client and server in pretty much exactly the same context.
I don't think that's explained my question well, but that's fine.
Okay, sorry.
Can I ask one other question, which is about what are you doing to deal with the callback issue in Node.js?
In Node.js?
Yeah.
The callback issue. You mean
exactly.
the callback spaghetti?
Yeah, exactly.
I think the main thing is to keep the apps really small, right, and keep them talking to each other.
You're actually adopting a microservices
Yes.
architecture in parallel.
Yes.
Okay.
And Kraken is very, because Kraken is so opinionated about the way it does certain things. There are certain things, there are certain ways to do things which are a lot less spaghetti than people are quickly inclined to do. Last question. And then.
So it's more, less technical, more HR question. So you're saying you switched a lot from Java to what? Did you have people? Did you have Java developers switch to the right node?
Both. Yeah, the point is there's a lot of Java developers that were looking to do something different, right? So we were losing Java developers that were going from leaving us to go for other companies where they were able to do Node, right? But we also had a lot of people coming in that were just excited to work on a fresh new framework, a framework that is pretty young, pretty hip, and they still had a lot of things to say about how it would evolve. So that was a good way for us to do recruitment. I think I need to leave because I think my time is up, way beyond up. Okay, thank you for your time. Cheers.